Okay, we're going to be looking at some different exponent rules or exponent properties that you guys will see when working with exponents. So real quick, just a few definitions here. When we have something that looks like this, x to the fourth power, we call like the big thing being raised to that power, we call it the base. We call the little number up here the exponent. So when you hear me say base, you know we're talking about the thing being raised to the exponent. When I say exponent, I mean the little number on top. And so let's make sure we understand what exponents really mean. If I have x to the fourth, like we wrote right here, that really means I have x times x times x times x. I have it 4 times. So we can write it in what's called exponential form. That's just like what it sounds. It has an exponent. Or we can write it in expanded form, where we actually write out however many of them we have. So we're going to do different operations with exponents today. We're going to multiply them, we're going to divide them, we're going to raise them to another power. And we have some different rules that we're going to use when we talk about those exponents. So the first thing we're going to do is multiply things with exponents. So before we actually look at the examples, I want to make up an example for you right here. If I have a to the second times a to the third, well, let's think about what that really means. A squared really means a times a. A to the third really means a times a times a. So in total, we have a times a times a times a times a. Well, if we condense that and write that in exponential form, we have a to the fifth power. Okay, so you can probably look and kind of see how we got from those two products to our final answer, but let's do it one more time before we actually talk about our rule. If I have 2 to the fourth times 2 to the third power, we can rewrite this. 2 to the fourth is 2 times 2 times 2 times 2. 2 to the third power is 2 times 2 times 2. So now if we condense this again, we have 1, 2, 3, 4, 5, 6, 2 to the seventh power. So you probably notice here, if we start out with the same base being raised to powers and we're multiplying them, kind of a shortcut to do this is all we have to do is add our exponents. You can see that in both those examples I made up right there. So that's what gives us our product rule of exponents. Our product rule of exponents says when we have the same base being raised to powers and we are multiplying, there's not a multiplication dot written here, but we know that means multiplication. All we have to do is add our exponents. We do not change our base. Notice here our base stays the same. We add our exponents. So let's do a couple examples of this. Okay, notice we have the same base being multiplied. All of those are our bases. And they're all being raised to different powers. I know that last one does not have an exponent written. If there's not a power written, that means that we have a power of 1. So if we do that, we keep the same base and we add our exponents. We're going to have 2 plus 6 plus 1. Well, that's going to give me 3 to the 2 plus 6 is 8, plus 1 is 9th power. So when we see things with exponents being multiplied, we add our exponents. Okay, our next example here, we're throwing some coefficients in here. With coefficients, we just multiply them like normal. So this says 2 times 5, that gives us 10. All right, let's take our variables letter by letter. I have an x to the third power times the x to the first power. Well, our rule up here says we add them. 3 plus 1 is going to give me x to the fourth power. Okay, let's do our y's. We have y to the fifth, y to the second. That gives me y to the seventh. And our z's, we have z to the first, z to the third. Gives me z to the fourth. So our product rule says we multiply our coefficients, we add our exponents. Okay, so now let's do kind of the opposite here. We are going to be dividing with exponents. Kind of the same way we did up here. I'm going to give you an example really quick. If I have x to the third, actually let's do x to the fourth divided by x to the third. Okay, so if we write this out, x to the fourth means x times x times x times x. x to the third means x times x times x. And we know if we have the same thing on top and bottom of a fraction, we can cancel that. So 3 on top, 3 on bottom cancel, and I'm left with just x, or x to the first power. You can write it either way. So again, we could probably do this without writing it a bunch of times. If you look at what we started with, we said x to the fourth divided by x to the third is x to the first. So you can see there that kind of a shortcut to do this is we're going to subtract our exponents. So that's what our quotient rule of exponents says. Quotient means division. If we are dividing exponents and we have the same base, that's key here, the same base, then all we do is subtract those exponents, the top one minus the bottom one. So let's do a few more of these here. A to the fifth divided by a to the second. We're going to use our quotient rule that says subtract them. 5 minus 2 gives me a to the third. Same thing here, we've got this same base, that's always important. We have a base of 7 on the top and the bottom. So if we subtract our exponents, we're going to get the same base, and then 13 minus 5 gives me an exponent of 8. Okay, the same is true like we did right above, where if we have multiple variables, multiple letters, we just take it piece by piece. We look at our coefficients and we see if we can divide those. We're going to divide 5 minus 2. We'll keep it as a fraction, which does not simplify. So I'm going to just leave that 5 halves. Let's take our a's. We have a to the third divided by a to the first. 3 minus 1 gives me a squared. B's, we've got b to the fifth divided by b to the third. 5 minus 3 gives me b to the second. And then our c's. C squared divided by c to the first. 2 minus 1 gives me just c, or c to the first. You can write it either way. So 2 ways you can write your answer. You can leave it like this. A lot of times you might see this written like this. The 5 will go in the numerator along with the a, the b, and the c. And the 2 will be in the denominator. You can write it like this or this, are both correct. Okay, another one of my exponent rules. Sometimes we will see a power raised to a power. So before we look at the rule here, let's just look at example 201. Let's think about what this means. This means I have a squared 3 times. Okay, so technically this means I have a squared times a squared times a squared. Well, think about what we did the first rule. A squared means a times a times a times a. So we've expanded this. Now if we want to condense it back, we've got a times a times a times a times a times a gives me a to the 6th power. So if we go back up to our original problem, you can see what we did here. If I have a power raised to a power, all we have to do is multiply those. 3 times 2 gives me a to the 6th. So that's what our power rule of exponents says. Power rule is what we do when we have a power raised to a power, and our rule says that we multiply those, our outside exponent times our inside exponent. So like on this next example, there's no exponents written here, so I'm just going to put a little 1. We have ab to the 3rd power. That tells me I multiply my exponents. 1 times 3 gives me a to the 3rd. 1 times 3 gives me b to the 3rd. So I have a cubed, b cubed. Okay, same thing is true on example 205. If we have a fraction where we have an outside exponent, it's being applied to the top and to the bottom. These both have a power of 1. So if we multiply our exponents, we get a cubed divided by b cubed. Okay, another example using multiple variables here. I'm going to stick a 1 with that y since there's not a power written. We're going to take our outside exponent times our insides. 4 times 3 gives me x to the 12th. 1 times 4 gives me y to the 4th. 2 times 4 gives me z to the 4th. So that is our power rule of exponents when we see a power raised to a power. Okay, a few more here that just get a tiny bit more complicated. Same process. We have a fraction, so this outside power, the entire fraction is being raised to the power, so it applies to the top and to the bottom. If it helps you, you can write it out this way. The 2 applies to the top and to the bottom. Or, if you don't want to take the time to do that, you can just remember we're multiplying here and we're multiplying down here. Okay, so let's look at the top first. I'm going to put a little 1 where I don't see an exponent. 3 times 2 gives me a to the 6th. 1 times 2 gives me b to the 2nd. On bottom, if we multiply, 2 times 8 gives me c to the 16th. 2 times 5 gives me d to the 10th. And we can't simplify this at all because we don't have any bases. If we look at our bases, we don't have any bases the same on the top and the bottom. So we just stop there. We can't simplify. Okay, and then one more here. If we have a coefficient out in front, be careful that we do not multiply this 3 times this 4. Really what we're doing is we're multiplying our exponents, this exponent of 1 times 3, or another way to think about that is we're just raising 4 to the 3rd power. 1 times 3 gives me 3, and then in your calculator we can just do 4 to the 3rd power. So if we have a coefficient, 4 to the 3rd power gives me 64, 4 times 4 times 4. If we multiply our exponents, 2 times 3 gives me x to the 6th. 3 times 5 gives me y to the 15th. Can't simplify anything else from there. We don't have any like bases, so we just stop. Okay, so I kind of gave you a synopsis of all the rules here, just to look back on so you don't have to flip to the front page. But these last 4 examples, we're going to kind of combine some of those rules. So if you look at example 209, we have multiplication going on, and we have an outside power. So before we take care of that outside power, we're going to take care of what's on the inside here. So we're going to use our product rule. Product rule says we multiply our coefficients and we add our exponents. So we have 4 times 5 is 20. X to the 3rd, x to the 4th gives me x to the 7th. Y to the 1st, y to the 2nd gives me y to the 3rd. Okay, from here we still have that raised to the 3rd power. So now we're going to multiply my exponents. So we get 1 times 3, which gives me 20 to the 3rd power. I'm going to go ahead and just type that in my calculator and see what we get. We should get 8,000. Multiply our exponents, we should get x to the 21st. Multiply our exponents, y to the 9th power. So sometimes you'll be using multiple exponent rules in one specific problem. Okay, similarly here, we have multiplication going on, and we have a power to a power. So before we do this multiplication, I'm going to simplify this power rule right here. I'm just going to bring down that 7a to the 3rd. Here I have 2 to the 3rd power, which gives me 8. Multiply our exponents, we get a to the 12th power. Now we can do our product rule, which says multiply our coefficients and add our exponents. 3 plus 12 gives me a to the 15th. Okay, then here, if we look at what rules we have going on, we have product rule going on. We have quotient rule going on. So I'm going to simplify the top first. If we multiply our coefficients, we get 30. We should get a to the 3 plus 4 gives me 7. B to the 1 plus 3 gives me 4. And then on bottom, we still have 2a to the 4th, b squared. So if we use our quotient rule now, quotient rule says divide our coefficients. That's going to give me 15. And subtract our exponents. So we get a to the 3rd power, b to the 2nd power. Okay, and then our last one here is a combination of, just a different combination of the same rules. We still have our quotient rule happening. We see that with the division. And then we have an outside exponent. So we have our power rule and our quotient rule. I'm going to go ahead and simplify that denominator. I'm going to keep this 3m to the 8th into the 12th. And then down here we multiply our exponents. So we get m to the 6th into the 9th. My quotient rule tells me to subtract my exponents. There's nothing to divide this 3 with, so we just keep 3. M's we have 8 minus 6, which is 2. 12 minus 9, which is 3. So 3m squared into the 3rd is our final answer. So again, here's that synopsis of all the different exponent rules right here. They can be used where there's just one single rule happening or where you have multiple rules happening at the same time.